We're going to go through how to write quadratics in mostly vertex form today, but a couple of the questions do standard form. It's very heavy algebra. So I do have the lovely vertex form, which you guys have seen. And if we have a test or quiz, I will definitely give you this formula. Guys, we don't need the computers right now, I don't think, so we could maybe put those away. But anyway, what we're going to do is write an equation that goes through these two given points. Now, if you have the vertex and a point, then you can write vertex form. If you were, we're going to do standard form in a couple seconds. That's not enough information for standard form, but this is enough information for vertex form. The most important part, if they tell you something is the vertex, you have to identify that vertex as H and K when you plug it into the formula. So we're just going to plug these numbers in, but it's super important. You can't mix these up. So the vertex has to go into that formula for H and K, and the point, so they'll give you another point on the graph. If we don't have a visual, then that's all we have to go. I guess we could draw a graph if you wanted to, but just with that information, I can write this equation. The only thing that you do not know in that formula is going to be A, and that's what that information is going to be used to solve for. Okay, so just super important, do not mix up the X and Y with the H and K, because if you do, you won't get the correct relationship here. So if I have this going through this point, the Y coordinate of the point is 9. So I'm just going to plug this into this vertex form right here. A is going to be our variable. All right, now it's the X coordinate of the point, so that's going to be 3 here. And it's minus the X coordinate of the vertex, which is positive 5. But that's why when we work on this, it looks like the opposite of what it is. So I'm plugging in the 9 and the 3, and then that's the point. The 5 and the 7, since that's positive 7, that just goes outside. Okay, please do not try to like distribute. I don't know why people do this. So like distribute this exponent to the 3 minus 5. Don't do that, okay? First thing you should do after you set this all up, just literally do like, what's 3 minus 5, right? That's negative 2 inside the parentheses first, okay? What would I get if I squared negative 2? 4, right? So I'm just going to put the 4 in front of the A. So this would be 9 equals 4A plus 7. And I know you can solve this in your sleep. I'm going to do 2 steps. I'm going to subtract 7. So 9 minus 7 is 2, and I get 4A. No one's writing 2, right? I know someone already did. What is my A value going to be here? 1. To get that A by itself, you got to divide by 4. People just automatically see 2 and 4, and they write 2. This is actually going to be a half, and that is your A value. Now, also important, and maybe annoying, this is not the answer to the question. The answer to the question is the formula in vertex form. So it's going to be a very similar structure to this. We're going to use X and Y, though, in the formula. So we're not going to use that 0.39 that they gave us. So in my answer, it should be Y equals. I figured out A. That was the whole purpose of doing that algebra there. So I'm going to have a 1/2. Put a 0.5 if you want to. I totally don't care if you want to do 1/2 or 0.5. Now, in the parentheses, it has to start with the X. And then it should be structured the exact same as what we did up here. It's minus the X coordinate of the vertex, so it's going to look like X minus 5. And then the Y coordinate of the vertex goes on the outside. That was 7. That is my answer. So I know it's a little bit extra, but you have to find the A value, and then you have to go back and actually plug that into the formula. So we should have an X and a Y. We should have our vertex, which they gave us in the directions, but we needed to do all that work to figure out the A value that goes in front of the parentheses. Is anybody having a question? Okay, now I'm just going to practice this with you one more time, but this one has some negative numbers in it. So whatever they tell you is the vertex, super important, that has to be in for H and K. Whatever they tell you is the point, that's going to go in for X and Y. A will be your only variable there. So the Y coordinate of the point is 40. I don't know A, so I'm going to have that little A in front of these parentheses. Grab the X coordinate of the point, which is 0. Now, if you want to skip this step, I totally understand. I'm going to write it out. It's minus the X coordinate of the vertex, which in this case, because that X coordinate of the vertex where I have H, that is minus a negative. That's why this always looks like the opposite when you do this, because minus a negative is really a plus. And then I just have the minus 8 on the outside. And then don't forget the squared on the parentheses, because that's the structure that gives you the quadratic when you square it eventually when we put an x in there. Now, in this particular case, 0 plus 4 is just 4. And I got to square the 4, not the a, just the 4. What's 4 squared? 16. So I would write that first term there is 16a. Don't square the a. People always screw that up. It's just the number that gets squared, minus 8. Now, to get a alone, get rid of the 8 first. So it's negative 8. I'm going to add it to the other side. And so I would get 48 is equal to 16a. And I just need to divide by 16 real quick. So a is going to end up being 3. Now, that's not my answer. I have to take and rewrite the actual equation. So it should start out with a y equals, I know a is 3, then in parentheses. Now, this is x minus the x coordinate of the vertex, but it's actually minus a negative, so it actually looks like a plus when you write the formula if your x coordinate's negative. And that whole little set of parentheses is squared, and then you just have the negative 8 on the outside, and that is our actual answer to the question. Is anybody having a question? Okay, now we're going to do one more down here, but this one is going to actually ask us to convert it into standard form. So if you have 2 points, which I'm going to here, this is the path of a volleyball, so it's going to follow properties of gravity, right? They're going to serve the volleyball, it's going to go up in the air, but eventually it's going to come back down. And if you read through this, which I'm not going to, I'm just going to cheat and tell you this, it tells you the vertex is at the point 120 on this graph. If the grid marks were better, you would be able to see that, I think. And then it also tells you that we have this point, which you could see on the graph is 0, 4. So it's just basically an application of what we just did. They're just going to give us the information, or you can pick it off the graph either way. So I have 2 points. I have the vertex, which is the 120. So that's going to be my h and k. And I have this point, which is 0, 4. That's going to be plugged in for x and y. When we do this, we're going to have to take this a little step further than we had to in the previous question, because ultimately this is going to ask us to write our answer in standard form. Okay, so I'm going to show you how to do that in a second, but let's do this first. So I'm going to do, let's see, my y coordinate of the point is 4. If you need to see this on the screen, I'm doing the vertex form first. I don't have enough information to just do standard form there. If you guys look at the standard form, you see how it has A, B, and C? That means I would have 3 variables, so I would need 3 different points. If I only have 2 variables, then I can solve with 2 points if one of them's the vertex for vertex form. But at this point, I don't have enough information to do standard form. So that's why I'm going to start with vertex. Okay, I don't know the a value. X coordinate of the point is 0 minus the x coordinate of the vertex, which is h. So that would be 1. That's all squared. And then plus k, which is 20. Now, in this case, this is a little nice because what do I get when I square negative 1? Like if you do negative 1 times negative 1, what do you get? 1. 1. All right, so really, I'm not going to have anything in front of the a here. It's just going to be 1a, right? Negative 1 squared is 1 plus 20. So we don't have to divide anything. I just got to move the 20 to the other side real quick. So this is going to be negative 16. And if anybody knows, negative 16 is the force of gravity feet per second, if you already know that. So that's what the answer should be there. Now, the actual equation, I'm going to come to the side. And I'm going to write in the sand a little bit here. So y equals negative 16 times x minus 1 squared plus 20 would be the vertex form. What the question wants you to do, though, and this is a little extra, wants you to write it in standard form. All you got to do to get standard form is just get rid of the parentheses here. Now, here's the major mistake people always screw up. Okay, they try to distribute that exponent. If you square something, what does that mean you're doing? Timesing it by itself. So this says x minus 1 twice. So that's what you want to write. You want to write x minus 1 twice. If you try to distribute that exponent, you will completely mess up how that's supposed to be multiplied because you'll be missing a middle term. So if you see something squared, I'm just going to try to get rid of these parentheses by writing it twice. Now, don't, like on the exponent there, do not distribute that 16 into that parentheses before you write it twice. Now, You can multiply in any order here, like you could do the negative 16 times the parentheses, then times the parentheses. I would not personally recommend that. What I usually tell people to do, let me just do like a FOIL or box or however you guys learned how to do this. I just think of it as like a little double distributive property. So I'm just focusing on these parentheses, get rid of these parentheses. So I'm going to multiply both terms by x, and then I'm going to multiply both terms in that second set of parentheses by -1. If you don't like doing that, that's okay. If you want to draw yourself a little box or something, you're welcome to. What do I get if I take x times x? X squared. No one said 2x. Someone said 2x this morning, and I about died on the spot. Okay, x squared. X times x is x squared. Please don't write 2x. If you did, don't feel bad, but that's not correct. Okay, x times -1 would just be -1x. I'm just going to write -x. Then I got to go -1 times both of the guys in the second set of parentheses. So -1 times x is another -x. Now, -1 times -1 is +1. Also, please don't write 2. Somebody said 2 this morning, and I was just not having a good health morning. All right, so not always, but pretty much most of the time, if you do kind of like a FOIL or box to multiply two binomials together, which is what I got going on, you'll have some like terms, and they usually end up in the middle that you can just put them together. So I've got x squared minus x would simplify to be -2x, and I have this +1. Okay, now you'll notice I kind of maintained those parentheses. That -16, sorry, out in the front is only being multiplied by that x minus 1 squared, so I kind of kept the 20 on the outside. I'm going to do a little distributive property. So I'm going to get -16x squared plus 32x. Negative times a negative makes a positive. -16 times 1 is -16. And then I have this +20. And then the very last step, you can just combine the -16 and the 20 there. So all this multiplied out in standard form is going to be -16x squared plus 32x plus 4. And if you guys wanted to check this, like you could put it in, you could like type the vertex form and type the standard form, both of those in Desmos, and you'd see they're both exactly the same parabola. Is anybody having a question? It's a little algebra heavy today. Okay, now on the back, sometimes if you have a graph, I just want to show you that maybe you could cheat a little bit to save yourself some time. So I have two graphs here, and the grid marks did not come out really well on this. I hope you guys can see them kind of okay. So this graph f of x, it's just y equals x squared. So that's the one that's centered at 0, 0. And it says it wants us to write the equation of this one, which is supposed to be g. And we can really just do what we did on the front. I just need the vertex, and I need the a value, and I need a point on the graph to do that. But I'm trying to write the equation of this graph that I just use my lovely little pink highlighter for. Okay, if you can't see this very well, I'm just going to label it on the picture because those grid marks are not the greatest that I've seen. All right, so that should be the point -1, 3, and that's going to be your vertex. Okay, if I've got to write an equation from a graph, we just literally do what we did on the front. We just have to find another point on the graph besides the vertex, and then we could do that same process. However, I want to see if you guys could figure out the a value without doing that process on the front. So I'm going to show you this. All right, so I'm just going to mark a couple points here as you go on this graph. And they're not super easy to see. So I'm just going to show you this real quick. I'm going over 1, up 1, and I'm going over 1, up 3. Does anybody know just from that information what the a value should be? It's 1. Okay, so if you can see the pattern on the graph, you could avoid doing everything that we just did on the front. We could just literally figure out the a value from the graph. It's not always easy to do that. We're going to practice that more in a second. But you might be able to just figure it out from the graph based on the patterns that you guys know that we've been using. So if this was me, I would literally just do this. So it would just be y equals, now, the a value is 1. So typically, I'm just going to write it with my highlighter, but that's not going to affect anything. They don't put a 1 in front of it if it's a 1. It'd be x, now, minus the x coordinate of the vertex. So if it's -1, it's going to look like a +1, because it'd be like minus a negative if you plugged it into that vertex form. And then your k is 3. So just +3. Now, this actually ultimately asks you to put it in standard form like we just did in that last question. This is just a little bit easier because all I have to do x plus 1 times x plus 1, but there's nothing in front for me to distribute. So I'm just going to do a little FOIL box, double distributive property, whatever you want to call it, and multiply this guy out. So x times x, x squared. X times 1 would be plus 1x or just plus x. Then I'm going to do 1 times both of those guys. So 1 times x is another 1x. 1 times 1 is not 2, is 1. Again, someone said that to me this morning after we did the other example, and I was like, whoa. All right, so x plus x. Combine like terms, you got 2x. Now, I can take the 1 and add that to the 3 that was originally on the outside of the parentheses, and then I've got my lovely equation in standard form. Is anybody having a question? Okay, now I'm going to give you the same problem. It's going to ask you to do just vertex form here, so I don't have to go that extra step. I just want it in this form, this x minus h squared plus k. All right, so grab the vertex. If you have a graph, grab the vertex from the graph. That's your h and k. So this looks like 3, 4. Can anybody tell what the a value is here without like finding a point and plugging it into that formula? It's not like a 1, 3, 5. What do you think? It's not -1. Okay, I want you guys to think about a couple of our patterns just real quick. I'm just trying to show you how to cheat. All right, so if it's 1, right, it's 1, 3, 5. If it's 2, it's 2, 6, 10, right? If it's 3, it's 3, 9, 15. So that first number in the pattern is the a value if you have the, like I could keep making other patterns, but it's because it's 1, 3, 5, the very first number, if the a value is not 1, is going to be the a value. So like what I would tell you to do, if you want to cheat a little bit, just go over 1 and then find your next nice point. Okay, so I go over 1 and then up or down the pattern, right? Can you tell how far down I go here? 4. Okay, so I'm going down 4, over 1, down 4. That means my a value, it has to be negative because it turns upside down, right? But if whatever you do over 1 and then up or down the pattern, that first step will be your a value. So if you have a graph, you can use that. If that doesn't make sense to you, just grab a point on the graph and you can do what we did on the front. But this is all I need. And this would just be y equals, we'd do -4 for our a value. It's x minus the x coordinate of the vertex. So it would look like x minus 3 squared. The k value is 4. Otherwise, you can do what we did on the front algebraically. You just grab another point on the graph and plug that in for x and y. You get the exact same thing. Okay, now, so I told you, if you go over 1 and then up or down, that should be the first step in your pattern, and that'll be your a value. However, if you get to one like this one I know right away this is going to be a fraction because it's a wider graph, and I'll show you how to cheat on this, but let me write down the vertex because that's the most important part I can grab from the graph if I got to do vertex form. So this is going to be 2, -1. That's your hk. Now, if you guys look at the lovely graph here, okay, if I go over 1 and I try to go up and meet the graph, right, if I go over 1 and up like a little bit, it's not on a nice point, right? If I go over 1, it's not on a nice point. Okay, now I will show you another way you can cheat a little bit if you have a graph. Try and find a point that goes right through a corner. So I've got the vertex, and then you're not going to see another one. And depends on which side you're looking at, but there are 2 other nice points on that graph. Okay, now I'm just going to draw like a little triangle between the vertex and one of those nice points. Anybody want to take a guess what the a value would be? It's a fraction. Any idea? Okay, you can do it like this. All right, if this, right, it's usually over 1, up or down the pattern, right? So whatever the pattern is here, it's a fraction because this is not on a nice point. If these two numbers match, if you can make yourself, this would be like a little like isosceles right triangle here. If you can make this, the a value is going to be 1 over that number. They have to be, those two sides have to be identical and they have to go through nice points. But if that's the case, your a value is 1 over that number. Now, if you're like, Miss Brody, I was not going to figure that out, that's totally fine. Just grab yourself, like the other, one of the points that I marked here was 5, 2. And you can do exactly what we did on the front. Just plug that in. I did y coordinate of the point, a times x coordinate of the point minus x coordinate of the vertex squared, and then y coordinate of the vertex, which is k on the outside. I'm just going to show you that you're going to get 1/3 if you do this. So I simplified this little set of parentheses. 5 minus 2 squared would just be the same as 3 squared. This is going to end up being 9a minus 1. I'd add the 1. So I'd get 3 equals 9a. And either way, if you want to use the graph to kind of cheat a little bit, or if you want to just do that algebraically, I get the same value. So it's totally up to you. If you don't like looking at the graph and doing that, you don't have to. You can just do the algebra. The actual equation then would be 1/3 times, what is this? X minus 2 squared minus 1 would be the actual equation there. Is anybody having a question? Okay, now I never do this, but I put some graphs just on the next page here just to see if you guys could figure out the a value just from looking at the graph. So this will take like 2 seconds. Just on this back side, just see if you could figure out the a value. So like on every single one of these, if you can go over 1 and then up to a nice point. So like on this very first graph, this is over 1, up 1, that a value is 1, just right away. Can anybody tell me what it is for the second picture? It's -1. You're going over 1, down 1. So if you go down, you just know your a. If it's flipped over, the a value has to be negative. Can anybody tell what is it for this third graph? It's -2, and that might just save you some time if you have a picture of the graph. Okay, now this one, the fourth graph on here, this is like over 1, and then it's not on a nice point. It's a little bit wider. Okay, so here's all I'm going to do. I'm going to try to find another nice point right here. Okay, so in this case, if it makes a little, the two legs have to be the same in the triangle. So this is 2, this is 2. If that's the case, if those are both the same, then 1 over that number is the a value. That one would be a half. I'm not going to give you anything that, I'm not going to give you like a 2/3 or something like that. If I give you a fraction, it'll be 1 over a number. Can you guys tell what it is for this fifth graph here? This one I think is 3. If you get to that next nice point, you're going over 1, up 3, so the a value, I know somebody said that. This last one I know has to be a fraction. So I'm looking to make a right triangle that has two legs that are the same. So let me see here. There is a nice point right here, but that would not make a right triangle that has the two legs being the same. So I'm going to see if I can find another, and I do have a nice point here. If you guys do that, it has to be a little isosceles right triangle. That just means the two legs, like the right angle would be right there. The two legs have to be the same. This is 4 and this is 4. I'm going down 4 here. So if you can make a little isosceles right triangle, the a value will be 1 over that number. In this case, it's negative because I'm going down, so it'd be -1/4. But just to give you some examples on a graph, if you want to cheat a little bit,